Okay, let's consider some nomenclature. So I have my zinc-copper reaction, and zinc is being oxidized because it's losing electrons. Copper is being reduced because it's gaining electrons. We've seen that definition before. And I have the electrochemical cell. This is called an electrochemical cell. When I have two half reactions connected with a wire for their electrodes. These are the electrodes here, like I have a zinc and copper electrode here, and this is the salt bridge, as you've seen before. And I've written 2 electrons, but there's a continuous current of electrons through the wire once this reaction starts. And we call the negative end, or the oxidation end, the anode. So we call this the anode. That's where the oxidation occurs. So we lose electrons at the anode and we gain electrons at the cathode. So the cathode is where the reduction occurs. And the anode is usually given the negative sign, the cathode the positive sign. So on your battery you'll have a plus and a minus sign. So the cathode is where the plus sign is, the anode is where the negative sign is. And you can think of this negative sign repels electrons. So negative charge repels negative charge. So this negative charge is pushing the electrons away from it, and the positive charge on the cathode is attracting the negative electrons. So that's one way of keeping track of the signs. Now, if we set up our electrochemical cell and it runs spontaneously in this direction, we call this a voltaic cell or a galvanic cell. So these are 2 words for the same thing. So that means the electrochemical cell runs spontaneously. So we have zinc as the anode, copper as the cathode. So this is a spontaneous reaction. Electrons will move from left to right, from anode to cathode, spontaneously, meaning delta G is negative for this process. And so if it runs spontaneously in this direction, then we call it a voltaic or galvanic cell. If we have to drive the cell, like if we set up copper in the left, zinc in the right, if we set the cell up backwards, we would have to force the cell to run in the opposite direction. And we could do that by plugging it in the wall, and that's called an electrolysis cell. So an electrolysis cell is running in the non-spontaneous direction because we're forcing it to.